And welcome back. It's the 22nd of April, Further Maths 5 a day, and let's just go straight to the first one. Okay, so it says work out, give your answer as a single fraction. So obviously the key is telling you what to do, single fraction, simplest form. Now, because I can think ahead a little bit here, the lowest common multiple of 4 and 3 is going to be 12, and the lowest common multiple of x cubed and x squared is going to be x cubed. So I'm going to make that into my denominator. Then I'm going to think what I need to do to first fraction to make the denominator 12x cubed, and that's to multiply it by 3. And 3 times 8 is 24. Similarly for the second fraction, what do I need to do to make that into 4x cubed? Well, I need to multiply by, so 12x cubed, I need to multiply by 4x, and so that's going to give me plus 28x. And on the face of it, that's it, but it's not, because I've noticed I can factorise the top, and I think that will cancel with the bottom as well. So if I factorise the top, that's going to give me, well, I can divide by 4, so let's take a 4 out, and that's going to give me 6 plus 7x. And if I look at the bottom, I can factorise that down to 4, lots of 3x. I don't really need to write that step, but it's just so you can see what I'm doing, which means I can cancel my 4's. And that ultimately leaves me with a final answer, which I'm going to go with, and I'm going to submit to the examiner, of 6 plus 7x over 3x. Where's my squared? Where's my cubed gone? Right, okay, let's correct this. I'm trying to do it too cleverly. That's 3x cubed, which means that's 3x cubed. We got there eventually, but that's okay. Yeah, a silly error. Do be careful of doing that. I mean, that is a classic me trying to do it too quickly, but equally, a bit of experience. I kind of knew it didn't feel like the right answer. We got there anyway. Next question. CDF is a rhombus. Find the area of CDF. Okay, so the keyword is rhombus. So rhombus means all these sides are the same, which means this is 10 as well. Now my technique is to take a triangle and multiply it by 2. And that is because I know the area of a triangle is a half times the product of the sides, so 10 times 10 times sine of the angle in between them. I've said this a few times, you may not have got to that yet. This is often the last thing taught on a course. And so that is going to be, well, a half times 2 is 1, 10 times 10 is 100. So that's going to be 100 times sine 120. Now, this could be a non-calculated question, couldn't it? So let's remember that sine 120 is the same as sine 180 minus 120, which is sine of 60, which is root 3 over 2. So that's going to be the same as 100 times root 3 over 2, which is the same as 50 root 3. And that is going to be my final answer. Now, if it was not a calculator exam, so not a non-calculator exam, it might say to you, give your answer to 2 sig fig or 3 sig fig. So just so I've done it, in brackets, that is equal to 86.6. However, to 3 sig fig. However, if it doesn't say do that, if it says leave it in exact form, and of course it doesn't say anything in this question at all, then you must leave it like this without writing the bit underneath, because otherwise you're showing you don't know what exact form is. So read the question, do what the question wants. If the question doesn't say anything, either of those two answers will be fine. Next and final questions today. Okay, this looks like it's got quite a lot to it, so let's do this one carefully. So a curve has equation, gives me an equation. The normal to the curve, so normal is obviously the negative reciprocal of the tangent. The normal is parallel to the line with this equation. Find the equation, the normal at the point A. Give your answer in the form. Okay, clever. So what it wants you to do is, there are quite a few steps here. So let's do it. I mean, not literally step 1, step 2, step 3, but let's do it in bits. So x minus 6y equals 2. I can rewrite as y. Again, all in one go, slightly dangerous, but I'm going to do it anyway. So y equals a sixth x minus 2 over 6, which is minus a third. I don't really care about the minus a third bit. What I do care about is the gradient of the normal is equal to a sixth, which means the gradient of the tangent, or the dy dx, is equal to minus 6. That's the bit I want to get to. Now, if I go back to my equation, y equals 4x squared plus 2x minus 3, I want to find out the gradient function. Well, how do I do that? Well, I differentiate. So if I differentiate, that's going to give me 8x plus 2. And remember, I want that gradient with the gradient of the tangent, which is minus 6, which means that 8x equals minus 8, which means that x is equal to minus 1. Right, I've got my x value. Now I need to find out my y value. So remember, what am I trying to do? I'm trying to find out the equation of a line And in order to find out the equation of the line, I need the point. And in order to find the point, I need the x and the y value. So I've got the x value. So in order to find the y value, I'm going to put it back into here. So y of minus 1 is equal to 4. Minus 1 squared is 1. Plus 2 times minus 1 minus 3. 4 minus 2 is 2. Minus 3 is minus 1. So actually my point, the point A, is the point minus 1 minus 1. And I've got all the ingredients now. So remember, I still need to go back to what I'm trying to do, which is find the equation of the normal. So the normal is going to be y equals mx plus c. And I know my normal gradient is a sixth, x plus c. I'm going to use minus 1 minus 1, which means that minus 1 equals minus a sixth plus c, which means that c must be, well, I'm at minus a sixth, and I want to get to minus 1, so I need to take away another 5/6, and we got there eventually. And let's put the final answer over here. So y is going to be equal to a sixth x minus 5/6, and that is my final answer that I'm giving to the examiner. And that's it. Good mix of questions again today, as ever. These sheets are really good, which is why I think it's worth doing this. Let me know how you did today. Hopefully you got them all right. Either way, do like, subscribe, and I'll see you tomorrow. Thanks all.